Hi everyone, in this video, this is the second part of the series on longitude and latitude. I captioned this one calculation of distances. I have two questions on the board. The first one says 2 points x, 32 degrees north, 47 degrees west, and y, 32 degrees north, 25 degrees east are on the Earth's surface. If it takes an aircraft 11 hours to fly from X to Y along the parallel of latitude, calculate its speed correct to the nearest kilometer per hour. The radius of the Earth is 6,400 kilometers. Pi equals to 22/7. Now, for you to understand what I'm going to do here, if you have not watched the first part of the videos on longitude and latitude, I advise you to look for that one, watch it so that you're able to understand what I'm going to do here. Now, to solve the question, you have to use a sketch to illustrate the question. You draw your Earth surface, put your poles north, south, east, west. Then you locate the points for X. 32 degrees north, anywhere here can do. 32 degrees north. Then 47 degrees west. 47 degrees west. So the point of intersection, you label it your X. Then for Y, 32 degrees north, we have drawn that already. 25 degrees east. east. So where the two meet, you label it your Y. Now, you will form a triangle. Once this is done, the sketch is complete. If you look at this sketch, you discover that both points are on the same longitude, on the same latitude. It's even it says both of them are along the parallel of latitude. Now, the calculations are into two. We have calculations based on distances along the parallels of latitude or along the lines of longitude. In this case, both of them are on the same parallel of latitude. So this is distance along parallel of latitude. Then it says calculate its speed. We are looking for the speed of the aircraft. Speed is equals to distance over time. And in this case, we are talking about the distance from X to Y. So we can say distance XY over the time it took the aircraft to move from X to Y. We are given that as 11 hours. So we need to calculate the distance. We already have the time. We know the time, 11 hours, but we don't know the distance. Now, distance for 2 points that are along the parallel of latitude is given by theta over 360 times 2 pi r. In this formula, we have small r. Why? All parallels of latitude are small circles. All parallels of latitude are small circles. Their radius is not taken from the main radius of the Earth, which is 6,400. Then this small r, the formula is big R cos alpha. So the big R is the 6,400 given. Then what about the alpha? The alpha is that latitude where both points lie. That angle of latitude where both x and y lie. That is your alpha. So our alpha is 32. Is 32 degrees. That is our alpha. Now, we need to do this calculation. First of all, let's find our R. What is our R? Using this formula. So R equals to, our big R is 6400 cos 32. And if you use your calculator to work it out, it will give you 5427.5 kilometers. That's what it will give you. Then, having found the small r, we will now go to the formula proper. And that will give us distance equals to theta. What does this theta represent? Please listen. Anytime you discover that the 2 points are on the same latitude, your theta means difference in longitude. Anytime the points are on the same latitude, theta will represent difference in longitude. But if the 2 points are if they lie on the same longitude, it means your theta will be difference in latitude. So what I'm trying to point out is that as long as the points lie along the same parallel of latitude, your theta will be difference in longitude. Then, in calculating this difference in longitude, you check if the two lines of longitude are of different poles, then you add them. In finding this difference, you add them, you add the two. But if they are of the same pole, maybe west-west or east-east, you subtract. In this case, one is east, one is west, the other one is east. And because of that, because they're of different poles, we have to add to get the difference. So in this particular case, our difference in longitude will be 47 plus 25. And that will give us 72 degrees. That's what it will give us 72 degrees. So it's going to be 72 over 360 times 2 times 22 over 7 times 5427.5. Now, if you multiply all of that, you will get 17194,320 all over 2520. You multiply all the numerators, multiply all the denominators, this is what you get. And then when you do the division, it will give you 6823.14 kilometers. So this takes care of the distance, but that's not where it ends. We are looking for the speed. So we have found the distance between x and y. The next thing is to calculate the speed. So the speed will now be this distance, 6823.14 over the time, which is 11 hours. If you do the division, it will give you 620.29. And the question says to the nearest kilometer per hour. So the nearest kilometer is 620 kilometer per hour. That will be our final answer. The second question says an aircraft leaves town A, 26 degrees north, 66 degrees east, to another town B, 24 degrees south, 66 degrees east. Calculate to the nearest kilometer the distance between A and B. Radius of the Earth, 6,400 kilometers, pi, 22/7. Now, in this question, you need to, as usual, put up a sketch, put your pose. The first point, 26 degrees north, 62 degrees east. Don't forget to put your pose. So where the two meet, you label it your A. Then for B, 24 degrees south, and then 66 degrees east. So where the two meet is your B. Then you form a triangle. That's the end of the sketch. If you observe very well, you discover that these 2 points, A and B, are on the same line of longitude, while in the other question, the other one we solved, both of them are on the same line of latitude. So that's why the two diagrams are not exactly the same line of longitude. And because it's on the same line of longitude, the distance we'll be looking for is distance along the line of longitude. And all lines of longitude are great circles. All of them are great circles, including the equator. Equator is also a great circle. They have a common radius, which is the radius of the Earth, 6,400 kilometers. So the distance here, the formula will be theta over 360 times 2 pi big R. In the first example, we use small r. The reason is simple. The 2 points were on the same line of latitude, that is parallel of latitude. Why in this one, and all latitudes, all parallels of latitudes, there are small circles. But in this one, both of them lie on the same line of longitude, and all lines of longitude are great circles. They use the radius of the Earth, which is big R. With this in mind, we continue. Theta here. In the first one, I told you, when the 2 points lie on the same line of latitude, we talk about difference in longitude. But when both points lie on the same line of longitude, theta becomes difference in latitude. So that is how it works. When the 2 points are on the same line of longitude, we talk about difference in latitude. But when they are on the same parallel of latitude, we talk about difference in longitude. Now, in calculating difference in latitude, we check the poles. If they are of the same pole, we subtract. But if they're of different poles, we add. If you look at the two lines of latitude, you discover that they are of different poles, 26 north, 24 south. So we are going to add them. So in finding the theta, which is difference in latitude, we'll add 26 plus 24, and that will give us 50 degrees. So the distance will now be 50 over 360 times 2 times 22 over 7 times 6,400. If you do the multiplication, it will give you 14080,000 over 2520. Multiply all the numerators, then multiply the denominators. Then when you finally do the division, it will give you 5587.30. The question says to the nearest kilometers. So nearest kilometer of this number is 5587 kilometers. In summary, we have two distances that we'll calculate. Either it is along the parallel of latitude or is along the line of longitude. And this will be clear to you once you illustrate the question, once you use the diagram to illustrate it. Everything will be very clear to you. And once you're able to draw the sketch, then the theta in the formula, based on what the sketch says, if the 2 points are on the same parallel of latitude, it becomes difference in longitude. But if both of them are on the same line of longitude, theta becomes difference in latitude. These are the areas you have to be very careful. And then finally, based on what you are asked to calculate, if you are asked to find the speed, this is the formula for speed, distance over time. But if you are not required to find the speed, calculate the distance and then you stop there. Thank you for watching and see you next time.